there's a couple of ways to do these. The first way is by writing a quadratic equation. Since that's what we've been working with, that's what we'll go ahead and start with. So we're going to take each one of these situations and turn them into a quadratic equation. They're going to be in factored form. So taking a look at the first one, A here. So the length of a rectangle, the length of a rectangle is 4 meters more than the width. So we're working with length and width. And then we know that the area is going to be 45 square meters. So we're going to set our width. We're going to say width is our x variable. And so we know that we're going to take 4 more than the width to get our length. So we can say x plus 4, and that's going to be our length. And of course, length times width, so we can take length and then multiply it times x, and we're going to get our area of 45. And so this is the factored form of a quadratic equation. If we were to distribute it, we would want to make sure that multiply the thing outside the parentheses by both things on the inside. We would end up with x squared plus 4x is equal to 45. If we didn't have a graphing calculator, we would want to make sure to set this equal to 0 by taking away 45 from both sides, and then we could either factor it to find solutions for x, or we could use the a, b, and c values to plug them into the quadratic equation to solve it that way. But since we have a graphing calculator, we'll just go ahead and use that first equation that we came up with. We don't need to worry about making sure there's an x squared in there. We'll keep it in factored form so there won't be any squareds, and we'll just go ahead and plug that into our Desmos. So the last lesson, we made use of that graphing calculator found at desmos.com, and so I'll go ahead and bring that up. Let's see here. Clear out everything I was working with before, and we'll plug in that equation started with, and we could put it the other way around. Instead of this parentheses x plus 4 times x, we could put that x in the front. Doesn't really matter, but it looks a little bit more familiar from what we're used to looking at. So let me go back over to Desmos, and we're going to put an x, and then we're going to put in parentheses x plus 4, close parentheses, and we know when we multiply width times length, in this case, we get 45. So if we were to use the quadratic equation or factoring to find, or the quadratic formula or factoring to find this out, we would end up with 2 solutions. We could either plug in 5 or that's a -9, I believe. Either one of those would make that true. However, in this case, we're trying to find the width of something, and a negative number doesn't make sense for that, so we know that 5 will be a good answer there. So we know that the width is 5. I'm going to go back over here. And our width was x, so if we take and add 5 to 4, we'll get our length. And so by that we know that our length is 5 plus 4, which is 9. And let's see here. Looks like we have a 5 and a 9 right there. So in the A box, we're going to start with the, and we can move on. I'm going to take a look at C here. It says length of a photograph is 1 centimeter less than twice the width, and the area is 28. So again, we can start off with a width of x. So starting that equation, I'll put x, and then we need to multiply it times the length, and we're going to get an area this time, area of 28. Here it says 1 less than twice the width. So first we're going to multiply. We're going to do 2 times x, that's twice the width. We want 1 less than that, so we're going to say minus 1. And that should give us the answer when we plug that into Desmos. So I'm going to go back over to Desmos, type that in, x parentheses, and then 2x minus 1, close parentheses, this time is equal to 28. Zoom back out, and this time we're working with the purple one. I'm going to turn off my green, and we've got 2 solutions, either 4 or negative, looks like negative 3.5. Of course, we want to choose the positive one, and so we know our width is 4. Go back over here, I'm going to say x equals 4, and then we also want to find out what our length is, so I'm going to plug in 4 for x here. 2 times 4 is 8, 8 minus 1 is 7, so we can say that our width was 4 and our length is 7. Try to find a 4 and a 7, looks like here. We are talking about centimeters, yep, looks good. And so B, the who, those 2 words don't seem like they work out very well together. There's one more way that we can use to find this. And so you could use this, you can plug in that one equation that you create, or you can do this using 2 equations. So I think I'll use the same C there. And so on every single one of these, we're going to be using length times width equals an area. And so if we keep our width at x, but this time we're going to say our length is y, then we have x times y, in this case, was equal to 28. That's one of our equations. And then our other equation, we're going to say that y is equal to 2x minus 1. So y was the length, was equal to 2 times the width minus 1. So we take both of these equations and plug these in to Desmos. xy equals 28 is the first one. Say x times y, so I can just put them right next to each other, equals 28. And that's going to give us actually 2 lines. So every point on that line are the x and y values that multiply together to give us 28. I think 4 times 7 gives you 28, so we have the point 74 right here, or the point 47 somewhere else right there, it looks like. And of course, if you have 2 negatives, they also give you a positive, so that's why we have x's and y both being negative, and they would, but we're only worried about the positives. So this was our first equation. The second equation said that our length was equal to 2 times our width minus 1, so I'm going to type that in. Y equals 2x minus 1, and the point at which both of these cross, this is the point that makes both of these true. And so we can use both of these equations, one of which is always going to be x times y equals whatever the area is, and the other one's going to talk about the relationship between the length, the y value, and the width, the x value. And so that 0.47 is the one where they cross. So that is the solution that makes both of them true. I think, yeah, if you go over here, you'd also have a negative version of those, but that doesn't make much sense to have negative lengths and widths. So we're going to choose the positive numbers, and we already did. We chose our 4 and our 7 there to solve our C. Oh, that's why it looks weird, because we skipped B and we went on to C, so get rid of that guy. And it was C that we did. So, all right, well, I'll let you guys choose whether you want to find the one equation just using x's, and it's a quadratic equation in factored form that you can plug into Desmos to find the answer. Or if you want, you can use the two equations, find where they cross each other, which also will tell those solutions. All right, that's it.